Hello everyone, welcome back to Enginuity Lab. This is video 9 of our CATIA V5 Beginner Solid Modeling Series. In today's exercise, we will convert the detailed 2D engineering drawing into a fully accurate solid model using CATIA V5 Part Design. We are going to convert this drawing today to solid model. This type of drawing is commonly used in mechanical assemblies, shaft, coupling parts, so mastering it is very important. Before starting CATIA, let's quickly analyze the drawing. This part is consists of a circular flange, a central hub, three equally spaced cutouts, you can see, and bolt holes. These are bolt holes for the bolt, and stepped bore profile shown in section A. Here you can see a stepped bore is created in this section A. This section is created from here. You can see this is 15 degree. This and this section is cut by this one. You can see section AA, and these cutouts are equally spaced at an angle 120 degree. And also this drawing in third angle projection. So if this is our front view, then this is our right view, but this is sectioned view. And all the chambers you can see here are 3 into 45 degree, like this one, all the chambers should be 3 into 45 degree. And in the section view, you see here the inner diameter is 20 mm. This one, the step cut, this is 26 mm diameter. Outer step, this is 34 mm. The outer diameter of this one is 40 mm. The main diameter or the outer diameter of biggest circle is 62 mm. Here the bolt holes are defined like this. There is a 9.5 mm of counter bore here, and the depth is 5 mm, and the through hole diameter is 5.5. Again, here the first step is 2 mm, up to this is 5 mm. This step, you can see this is start at 7 mm, and this is ends at 9.5 mm. This one is 13 mm. The center of this hole is 24 mm, and there are 6 number of holes, that is of diameter 6, and this is 23 mm. Here you can see from the vertical axis, and 24 mm from the horizontal vertical axis, and 23 mm from the horizontal axis. And here it is, the total overall length is 32 mm. So let's go to CATIA, start, mechanical design and part design. And I am renaming this part as solid model 9. Click on OK. Now we are into the part design workbench. Here first select a sketch plane. I am selecting the YZ plane and click on the sketch. Here how we can create? First we will create, here you can see most of the shapes is axisymmetric. means all these shapes are symmetry about an axis, about this axis, which means we can use shaft command for faster and cleaner modeling. Here we are going to use the shaft command. For that, what we will create? We will create the half section of this one. From the section AA, we will create the half section of this one. So first we will create this shape in the CATIA, which will be looks like this stone. Let's see which our shape is correct or not. You can see first we start from here, goes here, then this. Okay. Here we have done one wrong. This is not up to this. This will be here only, and trim those 2 point lines. Then give the dimensions. Okay. First of all, this dimension. This is diameter 62, means 62 by 2. We will create the half section of everything. Next dimension is 40, this one, and this one is 34. by 2. This one is 34 by 2. This one is 26. By 2, and the inner diameter is 20. So 20 by 2. Okay. Now give the steps. We'll take this forward to here. And we'll coincide this dimension with the vertical axis. Coincide. Next one, this is 2 mm and this is 5 mm. The first one, it is 2 mm. Let's select this one and this one. This is 5 mm. Okay. Then the step, inner step, which will be 7 and 9.5. Start at 7 mm and ends at 9.5 mm. And the next one is 13 mm. Now our flange or half is flange or half sketch is created and it is fully constant. Our sketch is fully constant, so we can click on the exit workbench, and here we will use the shaft command. For that, select the sketch. Here you can see profiler surface, select this one, and in the axis, select the axis. I am going to select the horizontal axis here and click on OK. Now up to this, our profile is created. Here this is created up to this much. Next one, we will create this shape. First, this is, here you can see 10 mm in between and 20 mm here. So how we can create? And this height is 32 minus 13. So click on this surface, click on the sketch and create this one. Okay. Create a circle for outer one. Create a inner circle as well. Okay. And the outer circle should be coincide with this one. So I can say coincidence, and the inner circle will coincide with this one. The inner one, I will coincide both the lines. And then this point should be coincidence with the outer circle. Coincidence. Same way this one is also coincide with the outer one. And here you can see this is 10 mm and both are symmetry. So I will create the 5 mm and this is 20 mm. So I will create it 10 mm in both the cases. First of all, this one, this is 5 mm. Okay, and this is, the angle is 120 degree. So let's make this one as 120 degree. Okay, and create another axis as well, which will be parallel to this one, or give this axis as angle 120 degree. This is a reference axis only to give the dimension of this one. Okay. Delete this one. This coincidence is not required, and give this dimension, distance, and it is 5 mm. Okay. Next is offset these two lines by 5 mm. On the left side you can see this is created, and give the dimensions, or you can give it from the center one. This is 10 mm, and from this axis this is also 10 mm. Now use the quick trim this one, trim the extra line of this one, and trim this one as well, trim this one. Similarly from the inner one, trim this and trim this one. Now our one profile is created. Go to the exit workbench and create the thickness or height by using the pad. Here the height should be 32 minus 13. So 32 minus 13 and click on OK. This is created. Now what we will do? We will do, select the pad and use the circular pattern command. Okay, and here we will create complete crown and 3 preview. Okay, now our 3D model up to this is created. Next we left with the counter bores or bolt holes and ditch holes. First we will create the bolts. For that I will create a hole here. This is located at, you can see, this is of diameter 50, pitch circle diameter, and this is 15 degree from the this line. So I will create this point here. First create a circle. This is diameter of 50 and this is a reference circle, so we will make it to construction lines and another axis which is 15 degree from the vertical lines, vertical axis 15, and at the intersection of both these I will create a point. Okay, and now this point should be a standard element. So now you can see a point is created. Here you can see a point. So what we will do, we will click on the hole command and click on the point, click on the surface, and here the type is counterbore and the counterbore diameter is 9.5 and depth is 5 mm and the through hole diameter is 5.5. So this is 9.5 and depth is 5 mm, you can see, and 5.5. This diameter is 5.5 and this is through all, so I will select up to next. Here it is 9.5 and 5 mm. Preview and click on OK. Now one hole is created, so for the other holes I will use the circular pattern here. Click on this hole, use the circular pattern, and here also I will select the complete crown and the reference element should be the y-axis. Okay, or 3 holes created. Next one, to give the holes here, to create holes here. For that also I will select this plane, YZ plane, and click on the sketch. Here I will create a circle. Okay, this is of diameter 6 mm and this is at 24 mm from the vertical axis and 23 mm from the horizontal axis. This is from the vertical axis, this is 24 mm. From the horizontal axis, this is 23 mm. Okay, and the diameter of this one is 6 mm. Now my sketch is fully constrained and click on the exit workbench. Use the pocket tool and I want this should be mirror extend and okay. Now one hole is created, 2 holes are created. Same way I will use the pattern command here, actual circular pattern, and here also I will use the complete crown option and the reference element will be y-axis and okay. Now everything is created here. Next, we will left with the chamfers. We will create the chamfer first. This is of 3 into 45 degree. So click on the chamfer. Here length and angle is defined. So click all the points where we will use the chamfer first. Then define the length. Length is 3 mm and angle is 45 degree. This is mentioned here. Click on OK. Now chamfers are created. Same way we have another radius here as well, which is of R1. So what we will do, this radius is here in this point. So we will select the edge fillet, this one, and the radius is 1 mm. Click on OK. Now our flange is created. From this sketch we create this 3D model. So this completes CATIA V5 solid model exercise 9. If this helped you understand shaft modeling, circular patterns and professional workflow, hit like and subscribe to Enginuity Lab and share it with your friends. In the next video, we will solve an even more advanced industry drawing. Thanks for watching Enginuity Lab. See you in next video.